Okay, this one I think is a little bit harder. So the setup is tricky for sure. A ship leaves port at noon and heads due west at 20 knots or 20 nautical miles per hour. At 2 p.m., the ship changes course to north 54 degrees west. Find the ship's bearing and distance from the port of departure at 3 p.m. Okay, so there's a couple things going on here. One, it changes course like in the middle of its trip. So that's a little bit tricky to kind of figure out on the diagram. And then also it gives you like clock times instead of like how long it actually was. So you have to do a little bit of kind of common sense there. But here's what's going on. I'm going to draw it a little bit more down like this. Okay. So here's my port. I'm going to call it P. It goes due west. So that's just along the axis. No, it doesn't look like along the axis. 20 nautical miles per hour. And it goes for 2 hours because that was from noon to 2 p.m. So this actually went 40 nautical miles. And then here's where it gets a little bit tricky. So it doesn't go back to port and then change direction. It changes direction here after 2 hours. So it's 40 nautical miles west of where we started, and then it changes its compass bearings. So north is still north, right? That is still my north-south axis on the compass. So we can still do compass bearing from here. Right, you just have to realize that we're changing direction out here. You don't go back to the port. So from here, it's 54 degrees west from north. So we are rotating from here 54 degrees. Okay, so the ship changed direction and started going this way. Okay, so that is a little bit confusing, but just remember that even if you're not at your starting point, north is still north, so you can still do the compass bearings from wherever you are. And then the rest of the information is this was just 1 more hour because we're looking at 3 p.m. So it traveled for 1 hour along this path, so that'd be 20 nautical miles. So the two things the question asks you is, where is the ship at 3 p.m.? Okay, in relation to where it started at the port. So you're going to connect wherever you ended up to the origin, and that gives us our triangle. And again, I do like to redraw the triangle, especially when it gets a little more complicated like this. I think it's helpful. So, but I'll keep my colors consistent. So I'll call this T for turn. I'll call this B for boat. So we have, this is 20, this is B, and this is T. This is 40, and here's the port. And we're finding the distance from the boat to the port. So part of that is actually figuring out this angle. Okay, so that would be, this is 90 plus 54. So this angle in here is 144 degrees using my information here. Okay, so you can kind of see it does get a little bit messy in there, so that's why I like to redraw the triangle. So the two things we want are, we want to know how far the ship is, so that's BP, and then we want to know the bearing of the ship. Okay, so you can see it's in the northwest quadrant, so we always do north of west. So what we're actually going to need in the end is this angle, but we're going to use the triangle to figure that out. So let's find the distance first, and then we'll get into the bearing. Okay, so this to me looks like SAS, so I would use law of cosines. X squared is equal to 20 squared plus 40 squared minus 2 times 20 times 40 times cosine of 144. Okay, square root that. And then I usually just type that in my calculator, like exactly what I have written there. So that gives me 57.40 nautical miles. Okay, so I'm going to add that to my triangle. 57.4. Okay, so this is kind of where my bearing is going to take place. I really am going to have to find this because that's what's inside the triangle. So I'm going to find angle P, and I'm going to kind of bring it back over to my original diagram to actually solve it. Okay, so this is the angle I'm going to solve for. I'm going to solve for it using law of sines. Okay, so I'm going to do sine of 144 over that side we just found is equal to, it's across from 20, so sine of P over 20. So we're going to cross multiply. We're going to get sine of P is equal to 20 sine 144 over 57.4. When I type that in my calculator, I get 0.2048. And to find P, I'm going to take sine inverse of that, which gives me 11.82 degrees. So the tricky part is that's not actually my bearing. So what that gave me was this piece. Here, maybe this is easier to see. They gave me in here, right? This angle P that it makes with the x-axis. What I actually need is the angle from the y-axis. So I'm going to do 90 minus 11.82 to get this piece right here. I'm also using second answer a lot in my calculator, so I don't have to retype everything. So I get that this angle ends up being 78.18 degrees. So my distance from port is this, and my bearing is, I'm in the northwest quadrant, and I am 78.18 degrees west from that north heading. So that answers the question.